Now I'll be moving on to trigonometry, question number 5a. And what I'll be showing you in this trigonometry question is usually question that involve proving. So what is proving? Proving is actually means that you need to prove left hand side of the equation is equal to right hand side of the equation. And usually it could be done by either choosing a side, by choosing one side to do. And it could be right hand side or left hand side. So to start off, usually for proving question, you usually choose the more complex side to solve problem. And here what we have here is cosecant square y secant square y minus tangent square y minus 1. And here actually is already a trigonometry identities where secant square y minus tangent square y is equals to 1. So applying this principle from here, we could just write that cosecant square y is equals to 1 and minus 1. And what we left here is cosecant square y minus 1. And cosecant square y here is also another trigo identities where cosecant square y minus 1 is actually equals to cotangent square y. So the final answer here that we got here is cosecant square y. And now we have managed to prove our answer, so we need to write here proven. And this is quite important to write, or else you will be deduct mark. And there are many alternative ways to solve this problem, but usually just to remind you that in exam there weren't much time given, so always use the simplest and fastest way to solve this. And good luck on your exam. And now moving on to question number 5b. So for question number 5b, as we can see here, both of them are the same, and when you can't decide which side to use, you could use either of the side, but remember to write at either each side the possible outcome of the previous things that could lead to the answer. And for example here, tangent square z can actually equals to sine square theta over cos square theta over sine square theta. And this could use as a reference for us. to ensure that we are on the right track. And this is quite a main huge tip. So now is, as usual, we'll be starting on left hand side, as this is what I usually use of. So now we'll be copying the question first. Tangent square z minus sine square z equals to tangent square z sine square z. So here is tangent square z can be derived from sine square z over cos square z, which is also another example for basic trigonometry identities. And here, and minus sine square z. And now we need to change these two base here to the same base. So it's by multiplying cos square on the sine square there, and eventually we'll get a function with the same base, a fraction with the same base, sine square theta cos square theta, and equals, and now we'll be factorizing sine square theta out, which what we left here is 1 minus cos square theta, and over here we have cos square theta. And now 1 minus cos square theta is actually also another trigonometry identities, where 1 minus cos square theta is equal to sine square theta. And so derive it from there, we could write sine square theta sine square theta, and over here cos square theta. And we could further separate these two, and this here could become a tangent. And now, which make our final answer tangent square z equals to sine square z. And this is our final answer proven. So remember to always write the reference to ensure that you are on the right track, and also keep an eye for trigo identities, like something that is basic as tangent, sine, cos, and this is some basic that come up quite often. And now is question number 5C. 5C is quite important, as I need all of you to take note on it, as this is quite a special case. And this case come up in the exam quite often. and often students can't solve it because they just get lost through the halfway of it. So really you need to be extra careful. And this is special because it uses both sides of equation. And this is usually used when you can't find when one side of the equation we can't find next step to do. Or it usually comes handy with the same solution of equation. And if you don't know what this means, never mind, as I will guide you later during this tutorial. So let's start it off as the usual. And this case is special because you'll be using left hand side and right hand side as well. So left hand side is, you could just start from sine theta, sine x over cos x plus cos x over sine x, as it was tangent x and cot x. So now we'll be changing them into fraction with the same base. So, and here we need to take note that there is another trigo identities. And as mentioned before, sine square theta plus cos square theta is equals to 1. So here is 1 over cos square theta sine theta, and if we can see here, we sort of start at here. And when you don't know how to do, you just start from right hand side. As right hand side, we have 2, so we factorize out 2, which means that what we left is 1 over sine 2 theta. And sine 2 theta is actually can be expanded into 2 sine theta cos theta. Can you see the similarities in here? As this is actually 2, but this is actually 1 sine theta cos theta, but only in the multiple of 2, which means that we need to multiply 2 in here. So continue, we multiply 2 in here, 1 per cos theta sine theta, and what we get here is 2 over 2 sine theta cos theta, which is usually the same as the right hand side. So we just copy the whole thing down, and then we'll be fine, and we'll get the answer, which is 2 cosecant 2x, and you need to write proven. So this is usually important, and there are things that you need to know, as during this both side there will be answer or something that is similar between both, which enable you to get answer. So just take note on that. And now I need all of you to take note on this question, as this question is considered as kind of a K-bar question, which require high order thinking skills. And it was quite hard, as well as it can be very tricky. So this here, something that we need to highlight is a triangle. ABC are angles of a triangle, and we need to prove them. So to start off, what we need to do is actually try and imagine a triangle. So usually a triangle got angle A, C, and B. And the total of this angle are usually 180. Which means that whenever we come to proving this equation, we could actually start off with left hand side equals to tangent 180 minus A plus B, which is true, as C, in order to get C, we need to 180 minus A plus B. So imply that theory from here, what we could get is, this is the basic trigonometry identity of tangent, and which you could refer to the table there. So we just like the tangent A and the B one. So here we got is a minus, and we need to continue. So write tangent 180 minus the same thing, tangent A plus B. But when you divide, is 1 plus tangent 180 tangent A plus B. And this is the formula of tangent A minus tangent B divided by 1 plus tangent A tangent B. So the same thing apply at here, and we just continue from that. Also take note about the special angle of 180 degrees and so on, or 30 or 60 degree or 90 degree and 45. And these are angles that exam will likely to came up. So back to that is tangent 180 is actually equals to 0. So here is 0, minus tangent A plus B divided by 1 plus a 0 tangent A plus B, which what we left here is negative tangent A plus B divided by 1 and is negative tangent A plus B. And we could also further derive it using almost the same trig identities of tangent, which is tangent A plus tangent B divided by 1 minus tangent A tangent B. And continue. So here is the same thing, which is tangent A plus tangent B divided by 1 minus tangent A tangent B, and equals to tangent A plus tangent B over tangent A tangent B minus 1. And in this case here, one need to take note that the negative here actually moved to the lower part of the equation, as negative doesn't necessarily just can be put on the upper above the fraction. It can actually apply on both sides, either it was upper or lower. So just take note on that. So in this case, we use a lower one, so it will not affect the value of tangent A plus B. And here we already proven, we just write proven, and don't forget. We move on to question B. Question B now is related to question A. So before I begin, I draw back the triangle that I draw at question A before. So another key thing important to be remembered is that tangent A plus B is equals to tangent A plus tangent B over 1 minus tangent A tangent B. Tangent A plus B 1 minus tangent A tangent B equals to tangent A plus tangent B. And then we could also take note from that tangent C can be further expressed into negative of tangent A plus B. As an example, tangent 100 degree is actually equals to 0.75, and the same goes for tangent of 80 degree, also equals to 0.75. So this theory is been used on here. and we draw something not to let us confuse by. So let's move on and let us start from left hand side. Left hand side, what we have here is, as we say before, tangent C is equal to negative of tangent A plus B. So we just express the whole thing. A plus B. And now we could factorize it by taking out tangent A plus B, where what we left is 1 minus tangent A tangent B minus 1. This is what we left with, and also after simplifying it, what we left with was just tangent A plus B and negative tangent A tangent B, which is equals to negative tangent C over bracket tangent A tangent B, and soon it will be expressed as tangent A tangent B tangent C. So we need to write, as always, proven. Okay, so good luck, as this is the last part of trigonometry, and I hope that you have excelled it.